Hello guys, this is day number 24 of our daily push-up challenge. This is now the penultimate session and we'll be solving a Putnam problem from the year 1977. So let's get started with a push-up.
1, 2, 3, 4, 5.
Okay, and the problem from 1977 reads, evaluate the infinite product, so you're multiplying from everything from n equals 2 to infinity of n cubed minus 1 and n cubed plus 1. Okay, so let's rewrite that expression right here. So you start from n equals 2 to infinity. Of course, when you start at n equals 1, you get a zero term, so everything will be 0. So that's why you start at 2. Okay, so you have n cubed minus 1 over n cubed plus 1. So let's try to expand this so we have an idea how each term looks like. So it starts at 2. So you have the first term looks like 2 cubed minus 1 over 2 cubed plus 1 multiplied by 3 cubed minus 1 over 3 cubed plus 1 and so on all the way up to the mth term. Okay, so let me try to adjust it here because I'm gonna write something on the left side afterwards. Okay, but let's write it again. 2 cubed minus 1 over 2 cubed plus 1 multiplied by 3 cubed minus 1 over 3 cubed plus 1, like I said, all the way up to, so this is the mth term, m cubed minus 1 over m cubed plus 1. And the thing that I'm gonna write is this is only equivalent to the left hand side of the equation if we take the limit of m approaching infinity. Okay, so that's what I was talking about. We need to move everything to the right because we need to write the limit. Let's continue the push-up.
6, 7, 8, 9, 10.
Okay, 10. All right, so the mth term, note that you can write the mth term as something like m minus 1 multiplied by m squared plus m plus 1, correct? And same thing with the denominator, I can write that as something like m plus 1, this time m squared minus m plus 1, okay? And so the first term would look, if m is equal to 2, the first term would look like 1 multiplied by, so 2 squared is 4 plus 2 is 6, so that's 7. And then in denominator, you have 3 times, so 2 squared is 4 minus 2 is 2 plus 1 is 3. And then the second term when n equals 3, so you have something like 2 multiplied by 3 squared is 9 plus 3 is 6 plus 9 plus 3. Wait, 3 squared is 9 plus 3 is 12 plus 1 is 13. Okay, and then in the denominator you have 3 plus 1 is 4. And then 3 squared is 9 minus 3 is 6 plus 1 is 7. And so on, all the way up to this mth term that we've simplified. And again, we need to take the limit as m approaches infinity. Okay?
11, 12, 13, 14, 15.
Okay, so you have 15. So now, what do we do? So let's look at like some patterns here. Okay, so you see something like these terms, they go, because you have a term here that is m minus 1. Okay, so when m is equal to 2, you have 1. When m is equal to 3, you have 2, and so on all the way up to m minus 1. So let's write that term here first. Let's rearrange the product since multiplication is commutative. We can always do that. So let's write the terms that I've encircled in red ink. So that's 1 times 2 times 3 all the way up to m minus 1. Correct? And similarly, the terms here, if you look, 3, 4, all the way up to m plus 1, right? So they are like behind the terms above, but they go further, they go up to m plus 1. So let's write that in blue ink. Let's rearrange those terms here. So you have 3 times 4 times 5 all the way up to, of course, before you even reach m plus 1, you have the terms m minus 1, m, and m plus 1. Correct? you have those terms. And then now let's evaluate the terms that are left. So you have these things in the denominator. Let's look at this in green. So you have 3, 7, and then all the way up to this guy. Correct? So you have 3, 7, all the way up to m squared minus m plus 1. Okay? And note that this guys, if you look at the pattern, this guys like cancel the remaining terms in the numerator that we have here. So what I'm talking about is, for example, this green thing will cancel this one. Okay? So in fact, all they cancel all the it's doing it again. My OneNote is closing on its own. So there must be a bug. Maybe I need to like update the software or something. But anyway, let's continue. So I was talking about this terms in the green, canceling some of the remaining numerators that we've not yet included in our rearranged product right here. Okay, but anyway, let's write these remaining guys. So we use some white now. So 7, 13, and so on. Let's write them here in the remaining part of the fraction. So you have 7 times 13, and so on, all the way up to m squared plus m plus 1. But then let's ask ourselves, what is the term before m squared plus m plus 1? Okay? The term before m squared plus m plus 1 is when m is equivalent to m minus 1. Let's say m prime minus 1. Okay? And when you do that, when you substitute m minus 1 in terms instead of m, you get something like, let's see, m squared minus 2m plus 1, and then plus m minus 1 plus 1, right? So this one will cancel. You get m squared minus m plus 1, which is exactly this term in the denominator right here, okay? So in other words, before reaching m squared plus m plus 1, the term before that is m squared minus m plus 1, and then you reach m squared plus m plus 1. Okay, so that's what I was talking about. So now you see here that some terms will cancel. For example, in here, so 1 is fine because 1 times anything is just anything. Okay, so but you see here the 3 will cancel with this 3. Everything the 4 will cancel with the 4 in here, and so on. Everything will cancel up to m minus 1. But then the terms m and m plus 1 will survive. Okay, this 7 will cancel with this 7. This 13 will cancel with the next term here, which is of course 13. M squared minus m plus 1 will cancel with this term, and then the surviving term is just m squared plus m plus 1. So therefore, we are left with the limit as m approaches infinity of, so you have, in the numerator, you are left with 2, and then so this 2, and then also another surviving term is 3, so you have over 3, and then the m terms you have in the numerator, m squared plus m plus 1 survives, and then in the denominator you have m times m plus 1. Let's distribute m squared plus m. Okay, we are now at 15,
16, 17, 18, 19, 20.
Okay, so 20. So now what do we do? Now we take the limit as m approaches infinity, and to make that work, in the numerator, let's divide everything else by m squared. So this becomes 1 plus 1 over m plus 1 over m squared. In the denominator, you have 1 plus 1 over m. So when you take the limit as m approaches infinity, this term approaches 0, this term approaches 0, this term approaches 0, okay? And so the final answer we have after evaluating everything is just 2 over 3, okay? So we are now at 20,
21, 22, 23, 24, 25.
okay. And so we're done with the push-up session, and also we're done with the problem. And again, things like this with an actual final answer, which is like a numerical value, you can always recheck it with something like Mathematica, which before even doing this, just to make sure that I'm confident that like the final answer I have is the right one. I inputted this problem to Mathematica, and it was able to evaluate it, and indeed the final answer given by Mathematica is 2/3. So I'm gonna post the screenshot of that Mathematica evaluation below the video. But anyway, thanks for watching, guys. Again, this is the second to the last push-up session. Tomorrow will be the last day of the 25-day push-up challenge. Again, this is the Putnam problem from 1977. Thanks for watching. I'll see you next time. Bye-bye.